All right, before we start up, let's talk about what we're going to do in the classes for the next couple weeks. All right, I'm going to go over a little bit of what's in the book on applets today, and then we're going to look at that code that I gave you. If you're interested enough in it, you can key it in. Is that an assignment? No. Well, then I'm never going to key it in. That's fine. All right, but I want to go over the stuff that's in there. Okay, and next week, I'm going to ask you this on Thursday, so if there is such a thing as a homework assignment like this, you're going to get 2 of them right now. You don't have to write anything down, but I want you to page through the last chapter in your book, which is on using Java and databases. All right? And if you want to go through that as a class, I'm not going to give you an assignment, but if you want to go through that as a class, let me know. And if you don't, let me know. All right? I've fallen a little bit behind on my grading. I've only got some of the stuff done. I will try to get it done as quickly as I can. All right? In much the same way, just so you know, with the C class. All right? Because I know last class was just a lab. But the plan is, again, Thursday will be a lab, just like today was. And then next week, I'm going to go over chapters. It's either 9 and 10 or 10 and 11. I think it's 9 and 10. It's on structures and advanced structures. All right? And then what I'm going to ask you to do, and I won't mention any names, Micah, but as far as what we're going to do for our last assignment, because there was one person in this class, at least, from the ones I've looked at so far, who did use pointers in his loan amortization program. So I'm going to have you do that, plus I'm going to have you set up something where you'll work with structures. So you'll already have the crux. Your logic will be done, so to speak. All right, so next week we'll talk about lecture on chapters 9 and 10, I think it is. All right, and then the week after that will be lab. Then after that, so that's like 2 weeks from right now, John's going to bring out the Macs. Travis is going to run. All right, but that's what we're going to start on. That's what we're going to be working with for the rest of the semester. All right. And in this class, then, it'll depend on what people feel as far as that last chapter. And we won't talk about it now. The other thing I want you to start thinking about is the class that you're taking, the classes for next semester. All right, there's a 152, 153, which is an Android class. 152, 156, which is an Android class. 152, 153, which is an iOS class. The internship class, and if you either have not done an internship yet or are looking to do one or whatever, then you have to come see me. All right? And I know some of you are working on internships that have been very bogged down for various reasons that aren't your fault. All right? But the other class that you take, the other one, is 152, 164, affectionately referred to as DIP, which stands for Design and Implementation Projects. All right, and I'd like you to think about what you'd like to have taught in there. What I have taught in the last couple of years, last year when we went through it, we went through some object-oriented PHP. I'm more than willing to do that again this year. All right, one thing I was thinking of doing, now, when you hear this, realize it's one class, it'll be an intro class. I don't even know the platform yet, but one thing I was thinking of doing in there was possibly starting to give you some game theory. All right, where we would build a game as a class. I don't know what we'd use. All right, if Mike Wegman hears that, he's going to go nuts, because he's been working with Unity, which is a platform that you can use for games. He's been doing it on his own, and he's actually getting his son, who's like 10, involved and having him write code. But just think about that and think about what it is you want to do. All right, now what we'll get to in just a couple minutes, so that you see this. This is the same code that I handed out to you, and when I run this, this is what you get. I'm still not sure why it's this size, but it is, and that's okay. All right, and when you click on this, notice it goes black. When you click on them again, they change. That makes sense to everybody as far as what's going on there? So we'll talk our way through that, all right? And like what I said is I want to take about 15 minutes and go over the crux of the chapter. I don't want to spend a lot of time on it. So we'll talk about this. If we get all that done before the break, then the second half is lab. If we don't get it done before the break, Then we finish whatever's left after lab. All right. This afternoon, I'm going to talk to you about, we're going to go over a couple chapters in ASP.NET. And in the late class, it's going to be a lab, the PHP class. All right. In PHP next week, then we will go over the 2 more chapters. And in ASP.NET next week, it will be lab. It doesn't work out magically that, wow, can we just have lab in all 4 classes? Then I don't have to show it all. All right. In fact, make it all 5. But give us a lab in Bootstrap too. Hell with it. I won't even come here for a week. It just doesn't seem to ever work out like that, whether I want it to or don't want it to. All right. So I guess the answer to that's no. All right. All right. So in this chapter, and again, I don't have the same book you do. It's got the same information, but this is an earlier version. So my page numbers, of course, don't map up with your page numbers. All right. But, introduction to applets, a couple minutes on that. A brief introduction to HTML. No, thank you. You already know HTML. All right. Creating applets with Swing and creating AWT for portability. I do want to talk about those a little bit, just so you hear that. All right. Then we get into drawing shapes. The main shapes that you can draw in Java, by default, rectangles, arcs, ovals, all right, and polygons. And the rectangles handle squares and they handle rectangles. Ovals are circles and ovals. Arcs are anything that basically are an arc, and you'll see that in just a minute. And polygons are they're kind of a hybrid. They're kind of like what's left. What they have you do in the example in here, one of the programs that's in the chapter here, is they use a polygon shape to draw a stop sign. Then they make it red. Then they use what's called drawstring, which we're going to get to in the period today, to write the word stop on it in white. So it looks like a real stop sign. All right. Then we'll talk about handling mouse events. Mouse in, mouse out, mouse over, etc. Some of the timer stuff that you can do in Java, and end it with talking about playing audio. So we'll hit all that. And it's not really going to take that long. All right. Bottom line, you can look at it because it's in red, etc. But the bottom line is, with what we've been doing so far, Java allows you to write programs in 2 ways. Applications, which is what we've done the entire last semester and this semester up till this chapter, or applets. Back in the olden days, like in the 90s, in the early 2000s, virtually any game you played on the internet was written as a Java applet. All right. It's not so much like that anymore. It's not that there aren't any, there are still plenty. But there are other languages that are more in vogue right now for doing that. All right. But the big difference is, as it says, an application is a standalone program that runs on your computer. That's what we've done thus far in this class. In here, in this chapter, we talk about applets. As it says, they're Java programs that are usually part of a website. So they run under a browser. All right. And you've seen these kind of pictures before. What I want you to understand, again, whether you have your book or not, doesn't matter. But it's kind of hard to see it in here. But this thing is in gray right there. All right. And what I want you to understand is that's the applet. Everything else on that page is HTML the author chose to add in there. To me, it's clutter, but that's okay. It's his book. He can do whatever the heck he wants. But the applet is here. And I believe the reason that Gaddis decided to bring this up now was he said, well, you've gone over how to create GUI applications. And you'll still be working with the GUI stuff in here. But now you have a better idea of what it's all about. All right. Again, this is fairly new. I'll let you look at that, but while you're looking at it, I want you to hear this. And that is, when Java was first created, the people in Java didn't realize this. It was full of security holes. What do I mean? It was possible I could have written a Java program that if I knew the path, for example, I might be able to go and read something off of Eric's machine. You could do stuff like that. You could write to other people's, if you knew basically where the path was to their files or to their directories, you could do that kind of stuff. That's not good. All right. So what Java decided to do when they came, it was somewhere between Java 1 and Java 2, they decided, and they were one of the first people to term this. If you've ever heard the term sandbox, you're in your own sandbox. So the idea is, you've got your own sandbox and your own sand, but it doesn't leave the sandbox, basically. All right, so the idea is any damage you do, you're doing to yourself. Well, like good little programmers like we are, that wasn't good enough for us. Because what we said was, but that's okay, but on this project, we've got me, we got Juan, we got John, and we got Michael. We're working in the same group. And what we want to be able to run our stuff and work on it together. So then they came up with the idea of a trusted applet. It's kind of like, you had public and you had private, and then they made protected. So there was something sort of in the middle. They're kind of doing that with trusted applets also. But by default, applets can't do any of the stuff that you see up here in the pink. All right, totally skipping the brief introduction to HTML. All right, so creating applets with Swing. I've said this to you before, but I want to say it to you one more time. When you work with GUIs in Java, there's two ways that you can work. You can build an entire application using the AWT, the Abstract Window Toolkit. That's the way it used to be done in earlier versions of Java. That was all that was available. The problem is, when you created components with the AWT, they oftentimes look different if you move them from one type of machine to another, one platform to another. It looked a lot different on a Mac as opposed to on a Linux box, as opposed to on an Intel machine, etc. That kind of thing. All right? So then they came up and they said, plus these AWT components, they're called heavyweight components. They're very memory intensive. So the people who work with Java, then they said, well, then let's create something that's more lightweight, that looks more complete on all sorts of different platforms, looks the same, or as much as possible the same. That's when they came up with Swing. So that's basically the difference between the two. All right? It says the differences, then they come in and they talk a little bit about the differences between using GUIs for an application and using a GUI for an applet. Well, what we're going to be doing now is we're going to be extending JApplet instead of like JFrame or JPal. That's one thing. All right? Here's another big one. There's no main method in an applet. For most intents and purposes, you replace main with a method called init. All right? They're not exactly the same, but they're very similar. Java also decided, the people who create this a while back, people complained and said, I want to be able to create an application, but I want to be able to run it as either an application or as an applet. So it is possible to do that in Java. And if you do that, you've got both a main and an init. All right, I've tried doing that to varying degrees of success in my time here. All right, so they start out real simple. Again, just to show you you're extending JApplet, just to show you that you don't have a constructor, you've got an init method, so they create a label that says, this is my first Java applet. And they set a layout manager, they add the label, they run it, and here's your actual program to test it. We're going to go over that in just a second. But that's what you get. This is my very first applet. Doesn't really do very much. All right? Typically, I keep hitting the wrong damn button. Typically, when you're running this stuff, that was on me. All right, so typically when you run this stuff, you're going to have a HTML file. Yeah, and I mean that, an HTML file that, for lack of better words, looks something like this. And that's the file that you use to run the applet. Now, I'm gonna go and copy this. And there's a reason that I'm going to copy this, and you'll see it in just a second. All right, now it just looks like one big happy line. You're used to writing HTML, for lack of better words, that looks like this. Oh, I guess you can put that up there. And if you just bear with me for just a second, I'll show you why I'm taking all the time to do this. So this shouldn't look that different other than this line from a typical .html file, okay? All right, that's the first thing. Second thing is, guess what? Java doesn't need this, and it doesn't need this. So why the author shows it to you like that is kind of beyond me, but he does. That's all you need. So when you want to run one of these and you need an HTML file, you need to put an applet tag in there. Then you say code equals, that is the name of your compiled file, your .class file, okay? This is the width you want it to be on screen and the height you want it to be on screen in pixels. So we're saying we want this to be 200 pixels wide, 50 pixels high. Does that make sense? So it's the same thing that's shown in the book, but you can strip out everything that's not part of the applet tag, all right? Now, back before the days when virtually everybody had a browser on their machine and everybody was either on the internet or could get on the internet in a matter of seconds, what Java decided to do was they decided to come up with a product. It was kind of an add-on to Java that was called Applet Viewer. And Applet Viewer allows you to run applets if you don't have access to the internet. Does that make sense? All right. So it's Applet Viewer, and you got to give it the name of your HTML file. All right. What they say in here is handling events in an applet. It's the same way. We do stuff the same way that we did it, you know, when we built the that conference registration program, and we started to do the things by hand. You could build an applet. You could use Window Builder, just like we did for when we went back and redid the conference registration program a second time. So the author's saying all this stuff, the way it's set up, none of that changes. None of the GUI stuff that you've learned changes. And then again, he comes in here and does the same thing. He gives you all that HTML here, and then all that HTML here and here, where again, the only thing you need in order to run that program is that line. Now, if that's all you put in there, you don't get all of the author's pretty stuff that he shows right here. All right, so you'd only get the box. And normally it'll come up in the upper left-hand corner then. You've got some control over where you put it, though. All right, I already mentioned this to you about the AWT and the differences between the AWT and Swing, so I'm not going to go through that again. All right, if you want to see some more of that, you can. The bottom line is this. Normally, when you're writing applets, you're going to import both javax.swing.star and awt.star. Okay? And if you remember that, you should be fine. The big difference, the AWT, instead of having a J label and a J text field and a J button, they've got a label and a text field and a button. You take the J's off, for lack of better words. All right? You run it the same way. It looks the same way. All right. jumping into shapes, and I think we've talked about this in other classes. If you look up on the screen here, that's in your coordinate system, that's 0.00 in the upper left-hand corner. So they talk here about 300 pixels wide by 200 pixels high, which means the width goes from 0 to 299, not from 1 to 300. And the height goes from 0 to 199, not 1 to 200. All right, because I've had people get all screwed up with that, forgetting that it starts at 0. When you work with graphics, as it says, each component that you work with is got something that inherits from a graphics class. That graphics class is fairly voluminous in size. That's one of the reasons that when you're working with applets that you have to import java.awt.star because that's the package that it's in. All right. And I think I mentioned this to you earlier, but I just want to say it again. It actually is important enough, believe it or not, to mention again. All right. So if you could imagine for a second that, so this is AWT. All right. So that's the Java AWT. Okay. And let's suppose underneath there, I'm making this up. So these names mean nothing. But I'm going to put under here package 1, package 2, package 3. And underneath here, I'm going to put in subpack 1 and subpack 2. In fact, let's move these over. There's a reason I'm showing you this. Like I said, I'm not trying to waste your time. And let's say under here we have just 1. So we'll call this subpack, we'll call that 1.1 and 1.2. And here we'll call this subpack 2.1. And this will just leave it the way it is. What I want you to understand is if I say this, if I say import java.awt.star, and I'm gonna walk up to the screen here to show you this. What this does by default is it only imports everything directly under AWT. So in other words, it imports this and it imports this. Does that make sense? Say that again. Right under AWT. So it imports package 1 and package 2 and package 3. Does that make sense? But it does not import the stuff underneath them.
Like subpack.
No, this stuff does not go in.
Okay.
All right, and I think the reason they did that was, and I was reading an article about this a long, long time ago, because what somebody wanted was they wanted to be able to say import java.star. That's what they wanted to do. And then everything in the world is available to you that Java has. Well, what about when we put the swing stuff? Fine, import java x.star. They didn't want to do that because the way, remember when you look, when you're under Eclipse and you've got a bunch of stuff that we looked at like the first day of class that were all these zipped library files? When you start to import stuff, you're making all that stuff available to your program. That's what you're doing, all right? But the way that Java works is it doesn't open it up unless you specifically ask for that to be opened up, all right? So in here, if I said import java.awt.star, I'd get these. Then if on the next line I said import java.awt.package1, then I'd get these. But I wouldn't get anything that's right underneath that. All right, and that's just the way that it works. That's the way it's always worked, and I don't think they're going to change it. All right, because I've heard people say, well, that's stupid. Well, somebody came up with that idea a long time ago, and to my knowledge, that's never been changed. Since it has never been changed, it probably never will be changed. All right, some of the methods that you might use, I think set and get color pretty much make sense. Hopefully you can look at this and that makes sense to you if you're drawing a line. That's your beginning X and Y coordinate, your ending X and Y coordinate. All right? Rectangle, same kind of thing, except instead of, these are your beginning coordinates, and then this is the width and the height of the rectangle. All right? When you draw a rectangle, by default, when you use draw rect, so let's say I made it red, okay? That would mean it would look like this. Just like that. In other words, it would be red, but the inside would be the same color as whatever your background was. If I choose a fill rect, Imagine I came in here and colored all that in red. That's the difference between a regular rectangle and a filled rectangle. All right? Then they talk about ovals. And it sounds a little weird, but this is just the way it is. If I create an oval, literally an oval is created inside of an invisible rectangle. That's just the way that it's set up. So that you're able to use a lot of the same types of things. Notice how it looks the same for the rectangle and for the oval. That's why. All right. When you get a little bit more complex, so when you work with arcs, you're working with angles. So you've got all that same stuff, but then you've got to have your start angle and your end angle. And then finally, when you work with polygons, it's more complex still. And notice then you're working with arrays. All right, we'll take a look at all of them in just a second. And finally, the last thing that's in here, don't worry about set font, because we've talked about fonts in a previous chapter. This right there, that's what you use if you've got a graphic and you want to write text inside of the graphic. All right, that's drawstring. So what I wanted to show you, though, was a couple things. There's an it. And again, as I said, that takes the place of a constructor. The other method that you always have in Applets is this one. Paint. Paint gets called by the system whenever the screen has to be redrawn for any reason. So imagine that you were creating a Java applet that was supposed to be like some kind of a kid's drawing toy. You'd be calling Paint all the time as they'd be moving their pen or whatever it would be, or their mouse or whatever across the screen. All right? You cannot directly call Paint yourself. You can't call Paint. Only the system can. But you can call Repaint. And what Repaint does is it sends a message to the system, as soon as you've got a little bit of free time, call Paint for me. All right? I'm just telling you this just so you know this. Paint, many of these different things that you do graphically require a graphics object. You don't have to call it G, but almost always that's what you see it called. Yes?
So would you use that to like make animations or something? Like paint, repaint, like every frame?
You would put it in a loop,
Yeah.
but the equivalent of that. But see, the thing is, when you write your logic, Paint will be called for you. The system knows, depending on, I mean, as long as you've written your logic correctly, it'll basically call it whenever it needs to be updated. So they show an example in here, drawing a red line and drawing a blue line. And again, they're giving you those coordinates. And you see when you get done, for whatever reason, he didn't put it in color, I guess, but those are the two lines. All right? And I don't think there's anything real hard about that. And he goes through the same things. He goes through then and shows you there's a draw rect and a fill rect. And then he goes through and does a draw oval and a fill oval. And he's got a couple of arcs. And then he goes through with the polygons. And this is what I mentioned to you before. So with polygons, he's basically declaring 1, 2, 3, 4, 5, 6, 7, 8 points. All right, in this example. And then he comes through and creates that. Then he says, well, this is kind of a good time to sit there and start talking about, he makes it red so it looks like a stop sign. And then he says, well, let's talk a little bit about drawstring. All right? Because it says here, if you want to put drawstring in there, you have to tell it where you want it to write it. And notice what happens. All right, hopefully that kind of makes sense. I didn't want to spend a lot of time on that, but I wanted you to see it. All right? Again, they talk about repaint right here. I've already mentioned that to you, so I'm not going to talk about that anymore. There's an example in here. It's kind of ugly, but if you look at it here, literally each time you check one of these, it draws one of those particular figures on screen. So if you do have any interest in this and want to take a look at it, this graphics window program is a pretty nice one to look at. All right, just two more things. The first is mouse events. when you work with mouse events, there's two different listeners that you have. Remember, when you see the word listener, think implement. All right? All right, it's not a class, it's an interface. So in other words, there is a mouse listener interface and there is a mouse motion listener interface. All right, the mouse listener does all these. You can read them yourselves. I don't want to read them to you. All right. On the other hand, so there's a little more detailed explanation in table 14.3. The mouse motion listener has just these two. All right. And what I want to show you about that is, and again, this is just the way that it's set up. I'm going to skip this first one because it doesn't demonstrate the point I want to show you. All right? But I want to go over the next one. Notice in this particular example, we want to put something in I think it's on the previous page. So we're putting something in mouse pressed. Everybody see that? So there's some code in there, down right there. But since it's an interface, we have to also put mouse clicked and mouse released and mouse entered and mouse exited, because those are all methods that have been defined in that interface. So even though we're putting no code in there, and a lot of times rather than seeing it like this, you'll just see an open curly, closed curly right there on the same line. All right, but you have to put those in anyway. Even though out of the 5, you're only using one of them, you have to still include all 5. That's because that's the way interfaces work. All right, timers. Some of the things that you can do with timers, all right, you can see if a timer's running, you can set delays for timers, you can start timers, you can stop timers. If I was going to write, for example, my own crude little text editor, I might set it up so that, you know what, every 2 minutes it automatically saves whatever it is you're working on. You know, you're all probably too young in here to remember this, but it used to be with most text editors, even things like Word, it did not auto-save for you. There was not a feature like that. So if you were working on it and somehow you weren't saving on a regular basis and you got a power hit or whatever, you lost what you had. Everything that was there was gone. So they write a program in here, and what that one does, I don't think they show it to you, but it shows a ball, basically, the equivalent of a ball bouncing up and down. All right? And the last thing that's discussed in the chapter is audio. Java supports most basic audio files, and when you work with them, you'll typically use them in one of 3 ways. Right there. If you want something to play one time, you use play. If you want something to play over and over and over again, you use loop. And unless you want to drive yourself nuts, you probably want to have some way when you're looping to stop. All right. In that particular program example that they have right there, in that example, what it does is they've got the sound clip from Neil Armstrong being on the moon. What is it? 1 small step for man, 1 large step for mankind, or something like that. So if you click the play button, it plays it once. Loop plays it over and over until you click stop. So in the example, that's what it looks like. All right. So the program that we're going to look at right now, in fact, maybe we'll take a break, but before we do, let's at least talk about it, okay? There it is. So again, I've said this kind of thing to you before, but think about this. If I was going to create the house, all right, I'd probably start right here. There's a rectangle, which is the base of the house. All right, that gives me that. Then I need a line, 2 lines for the roof. 1 line here and 1 line there. All right? Then I can really use another rectangle here for the door. I could do it as 3 lines, or I could do it as another rectangle. Let's say I do it as a rectangle. All right? Then I need some kind of an arc. I don't know where they show that over here or whatever. And that's going to be my doorknob. All right? Then I've got two more rectangles, one here, one here. Each of those rectangles has 1, 2 lines in them. Does all that make sense? All right. And there's other ways this could have been done. I guess technically I could have written four small rectangles there if I really.
All you need is two.
What's that?
All you need to do is two rectangles to make the lines.
Yeah, you're right. There's a lot of different ways this could be done. All right, and I've had people do it in many different ways. But when I've assigned this in the past, the hardest part has not been doing this. The hardest part is you have to do it mathematically. In other words, you can't just shoot the moon. And what I mean is, people, I would go over there, people would say, I'm having problems with it. And I'd see they'd have their rectangle, then they'd have where the roof's supposed to be, they'd have one line there and one line over there. Because they just start throwing it all over the. Well, this is good because it's teaching me about coordinate systems. Not very well. All right. So that's why you've got what you have in front of you. So let's take a break, and when we get done with the break, we'll go over this code. Spend about 10 or 15 minutes on it, and then that'll be it. All right. So think about that. We'll talk about it on Thursday. I'll give you Thursday as a lab day too. All right. And hopefully, if you're still working on the Joes. Now, if you got Joe's done and you got the first one done, if you don't show Thursday, that's probably why you're not showing. All right. So it's about 10:45. Let's come back around 11, please.